Here's a good one. Make sure you're taking notes in your packet. There's several times where I'll ask you to hit pause, and that is when you hit pause and actually work out the problems. It will ensure your success. Quick little review of triangles. There's a couple ways we classify triangles. One is by their side, and one is by the angles in the triangle. Let's go over here to the side one first. An isosceles sounds like Greek, doesn't it? Isosceles triangle has two equal sides. So you could write a little 2 in there in the middle of that triangle. An equilateral, it sounds like what it is. It has the word equal in it, right? All sides are equal and all angles are equal. It's equilateral, so it has 3. And scalene, all sides are different lengths. All sides are different angles. So this has 0 sides that are the same. Equilateral has 3 sides that are the same. And isosceles has 2 sides that are the same. And usually I just remember the equilateral has equal, 3. I remember that scalene has none, and then I know the Greek sounding one, isosceles, only has 2. You can also classify triangles by their angle. And this one's easy. If it has a right angle, and remember if it has a right angle, it generally will have a little box down here like that. We all know what that is. That little box means 90 degrees, right? So if it's a right triangle, it has a right angle in it. An acute triangle has 3 acute angles. And remember, acute angles are really small. They're really cute. Cute angles less than 90. And an obtuse triangle has 1 angle that's bigger than 90 degrees. It can only have 1 angle bigger than 90 degrees because otherwise it wouldn't be a triangle, which we'll talk about later. But here's some notes you should write down. All right. This triangle is all right because it's got a right angle in it. This one, it's cute. Acute, it's cute. It's small. And the word obtuse to me sounds kind of like this. It's an obtuse triangle. It has an obtuse angle in it. So those are your classified triangles by their side, which is the length of the side, or by their angle, like the angles on the inside. Page. Oh, my same page. You're on the same page. I'm on a different page. All triangles in the world, in the whole world, have 180 degrees in them. What that means is that this angle, and this angle, and this angle all add up to be 180 degrees. If they don't add up to 180 degrees, it is not a triangle. So if I said this angle was 35, and this angle was 45, I would add those two together. 35 plus 45 is 80. This angle would have to be 100, right? Can't do the math in my head. 100. Because it has to equal 180 no matter what. All right, what are we going to do today? Now that we've got our quick review, we're going to review the types of triangles. And then we're going to have to decide if it is a triangle. So we have to decide if the 3 lengths determine that it is a triangle. And we'll be able to draw triangles when they tell us. And we have to decide whether it's a unique triangle, more than one triangle, or no triangle. And those things can be determined by the sides. And it can be determined by the angles. Those are the only thing you need to know to determine, is it a real triangle? Sides and angles, just like we talked about in the first slide. All right, how to classify triangles. I copied this little page right over here for you. Let's go over some of these, right? Let's look at this triangle. They're going to give us triangles. This is what kind of triangle is this? Well, it looks like it's got 3 acute angles, right? So we know it's an acute. So since there's no right angle, we know it's not that one. There's no obtuse angle in here, meaning bigger than 180 or bigger than 90, so it can't be that one. And we said it's got acute angles, right? So we don't even got to solve too hard for that one. It's answer C. It's acute, and all these sides are different lengths, right? So it's acute and scalene, because remember, this has 0 sides, this has 3 sides, and this has 2 sides. Go ahead and hit pause right now and solve the rest of these problems. On the word banana, hit pause. Banana. Great, welcome back. I hope you did the work. I have a little hint here for the answer. Whoa, I missed the wrong thing. I have a little hint here that's not working for some reason. I'll move this one for you first. So on this side, 18 is B, equilateral, they're all equal. This one is B, right, has a right angle in it. See that little square right there? It means right angle. And this one down here is D, right isosceles. When you see a mark on there, that means this one's 1 and that one's 1, basically the same length. I don't know why I can't get the other one to move. Oh well, I'll do it for you. This one has what kind of an angle in it? It has a right angle, right? It also has 2 equal sides, so it's right and isosceles. So this one is D. And this one, we know it's got an obtuse angle, right? So we can cross out these two. Now, is it scalene or is it isosceles? Well, scalene means no sides are equal. Isosceles means 2 sides are equal. I'm going to go with B. Well, it's kind of hard to tell. I'm going to go with scalene, B, because none of those sides look like they're equal to me, but it's close. I can see how that one and that one are kind of close to you. All right, let's move to the next page. All right, this is important. This is a fancy word, triangle inequality theorem. I would put a star down there and I'll sum it all up for you. Any of 2 sides must be greater than the third side. And think about it, if we had boards or 2x4s, and one of them was 3 feet long, and one of them was 2 feet long, and one of them was 6 feet long, and I was trying to make a triangle, well, whatever the longest one is, so from here to here is 6 inches, right? Or 6 feet in my example. And I lay the other 2 boards on. Do those boards touch? This one's 3 and this one's 2. No, look they'll never touch. Because if from here to here is 3 and from here to here is 2 and the bottom is 6, it's got to be greater than 6. So let's see it. 3 plus 6, that's 9. That's greater than 2. So that works. 2 plus 6 is 8. That's greater than 3. So that works. But if I add 3 plus 2, that's 5. 3 plus 2 is 5. It's not bigger than 6. So basically this long theorem right here, okay, explains that it has to be bigger than the third side. So any 2 sides have to be bigger than a third side. So this one is not a triangle. Not. This one, they have 3, 2, and 5. Well, that seems a little closer, right? 5 plus 3 is 8. That's bigger than 2. 2 plus 3 is 5. Is that bigger than 5? No, 3 plus 2 equals 5. So that will never be a triangle either. It must be bigger. So this one is not a triangle either. Remember, it has to be bigger. It must be bigger. Cannot be equal. Let's look at another example here. So here I go through the examples, right? In my theorem, my little shortcut is that any 2 sides have to be bigger than the third side. So we got 3 plus 4 is 7. Is that bigger than 2? Yep. 4 plus 2 is 6. Is that bigger than 3? Yep. And 3 plus 2 is 5. Is that bigger than 4? Yep. So this is a triangle. Because I did my check and I noticed that any 2 of them added together is bigger than the third one. And like they wrote in nice pretty handwriting, yes, they do. Let's try a few together. So this one, 7 plus 5. 7 plus 5 is 12. That's bigger than 4. 5 plus 4 is 9. That's bigger than 7. And 4 plus 7 is 11. That's bigger than 5. So number 1, that's a yes. It is a triangle. Let's look at number 2. 3 plus 6 is 9. That's bigger than 2. 6 plus 2 is 8. That's bigger than 3. And 3 plus 2 is 5. Is that... Oh, wait a minute. 3 plus 2 is 5. That's not bigger than 6. That's a no. Let's look at number 3. 5 plus 2 is 7. That's bigger than 4. 2 plus 4 is 6. That's bigger than 5. And 5 plus 4 is 9. That's bigger than 2. Number 3 is a yes. I'll do one more with you. I see two numbers that are the same here. This one might be tricky. 8 plus 2 is 10. That's bigger than 8. 2 plus 8 is 10. That's bigger than 8. And 8 plus 8 is 16. That's bigger than 2. This one's a yes. So remember, as long as you add up two of the sides and they're bigger than the third side, that works. Go ahead and press pause when I say to. You're going to do 5 through 12 by yourself. Go ahead and press pause on the word banana. Banana! Hey, welcome back. Hopefully you'll actually press pause and work through some of those. Now, since you've got it, let's check our work. They're all yes. In all of these examples, when I add two together, it's bigger than the third one. So it's yes, 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 yes. Yes, 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 yes. I know you understand it. You're smart. It's easy. All right, get ready. On the word banana, I'm going to tell you to hit pause and solve. Remember, all these have to equal what? They must equal 180. If it equals 179, it's not a triangle. If it equals 181, it's not a triangle. So on banana, hit pause and solve those. Banana! Welcome back. There's my little guy screaming banana. All right, add these up together. That is not, right? 60 plus 80 is 140. 140 plus 90 is 230, not a triangle. 60 plus 60 plus 60, yep, 180, it's a triangle. 90 plus 45 plus 45, yep, 180, it's a triangle. This one is not a triangle. This one is a triangle, and this one's not a triangle. Remember, the way to determine, they must equal 180 degrees. All triangles in the world must equal 180 degrees. All right, here's something that's not a huge thing, but if you really think about it, it's easy to understand. So put a star by that. And when it says the word included, it really just means between. Okay, so when it says angle A over here is the included angle, well, here's AB, the side AB. Here's the side AC. Is it between? Yes, if it's between, it's included. So that's the included angle right there. And when they say included side, they give you an angle, right? So side AB is included or between this angle and in this angle. Included really just means between. And if you really think about the words, it's easy to remember. You don't have to remember anything. Included means between. Circle all the triangles with the side lengths of 8 and 5 and an included angle of 32. Well, let's look at it. Here's 8 and 5, but that angle is not between. It's not included. Here's 8 and 5. Is that angle between the sides 8 and 5? Yep. It's a triangle with an included angle. Here's side 5. Here's side 8. But is that angle between it? Nope. So this is the only triangle with an included angle of 32 between the sides 8 and 5. I know, it's easy. Circle all the triangles with the side lengths 4 and 3 and a non-included angle. Non-included. They're trying to trick you of 50. And it has to be adjacent. We know the word adjacent means next to. Has to be next to the side with the length of 3. So let's look. Here's a 4 and a 3. It's a non-included angle of 50. And adjacent means next to. This one is. Here's one that's 4 and 3. It's a non-included angle, right? My angle's 50 right here. Is that next to 3? Yep. It actually looks just like that one. I just kind of flipped it over. All right, here's 3 and 4. It's non-included. not included, right? It's 50, but it's not adjacent to the 3, right? It's next to the 4, so that one is not. And this one here's 3 and 4, and the 50 degrees is included, and they're looking for non-included, so that one is neither. This one says circle all the triangles with angles 90 and 28 with an included side of 6. So here we got 28. Here we got 90. Is that 6 between them? Yep. Here we have 90. Here we have 28. But that 6 is not included. It's not in between those. Let's look at this last one. We got an angle of 28. We got an angle of 90. I'll even draw the little 90 thing there for you. Is this 6 between 90 and 28? Yepers. Sure is. Easy, easy. All right, guys, it's homework time. When you finish, you can always work on IXL. The homework is quick. It's just like the examples we went over. If you need to look over again, go ahead. Have a great banana. I mean, have a great day. Have a great day.